Mute. Okay, I think this is mute, no problem. So again I will tell you, hello my dear, I welcome you again in this lecture of Score Booster, and this is part 2. Part 1 we already discussed this thing, metal casting, welding, metrology. These are the part first, and part second today we will discuss in detail metal forming, metal cutting operation, and non-traditional machining, and some questions related to the seam automation. So this is the first question, today's first question, which is related to the electrochemical machining. I will read the question first. Okay, so what is the question they are saying? They are asking, what is the question? The question is said that a researcher conducts electrochemical machining on a binary alloy. So there is a binary alloy, more than one, and the alloy density, this is a density of alloy, not for single material. So alloy density is 6000 kg per meter cube of iron, which is the atomic weight 56 and valency 2. And there is a second metal, let's suppose the metal P. First metal is your iron, second metal, let's suppose metal P, which atomic weight is 24 and valency is 4. Now, given the Faraday constant Coulomb per mole, it is given. If it is not given, you can, my suggestion is that you can remember this value, okay? 96500, 96500. The unit is Coulomb per mole. Volumetric material removal rate of the alloy. So this is given volumetric material removal rate, that means MRR, material removal rate, it is given. It is in meter cube per second. Meter cube per second, that means volume flow rate. It is a kind of discharge, okay? Sometime it is also given kg per second, mass flow rate. So sometime volume flow rate, sometime mass flow rate. So mm cube per second is the volume flow rate, gram per second it is the mass flow rate. So we will discuss this thing. And we supply a current of 2000 ampere. So they are asking the percentage of metal P alloy. What is the percentage of metal P? In this case, what is the percentage of metal P? How much the percentage of metal P? It is asking. The option it is given 40, 25, 15, 79. Okay. So my suggestion is that I will give this. मैं आपको कुछ time provide करूँगा. इस time के में आप इस चीज को देखिए. Okay. We'll start this time for 1 minute. Just start. Time's up. Now, I will give you some background. So this is your ECM, yes or not? Electrochemical machining, not EDM. This is your electrochemical machining. So what is the electrochemical machining? What is the mechanism? In this one, it involves electrolyte, that means anodic nature. This is your anodic nature, electrolyte, anodic nature, dissolution. electrolyte, that electrolyte dissolution of workpiece in contact with chemical solution, in contact with chemical solution. So these are the process of dissolution. These are the process of dissolution. Okay, these are the first thing. Second thing, it's have a highest material removal rate. All of the machining process, non-traditional, electrochemical machining is highest machining metal removal rate, and it is approximately 200 to 300 mm cube per second. Okay, and it works, matlab ECM, what is the principle? ECM works on a Faraday laws. It works on Faraday's law. It works on a Faraday's law. Now, so in this question, first we know that what is the material removal rate, MRR. So the material removal rate is your current passing into atomic weight divided by Faraday constant F into density into valency. This is the material removal rate during the electrochemical machining. Okay, and this is your centimeter cube per second. Okay, where Z is your atomic weight, Z is your atomic weight, which is in gram. Okay, and N is your valency of the corresponding material. F is your Faraday's constant. And this value is understood 96500, and rho is your density. This is your density, and this is your in gram per centimeter cube, mass by volume. These are the things. So these are MRR. Now, how to adjust this MRR with IZF rho n? So, my dear, for this one, see one thing. This is the first equation. Now, my dear, this is centimeter cube per second. If you multiply with the density, so see, my dear, centimeter cube per second multiply with density, that means gram per centimeter cube. So this centimeter cube cancel. So this is your gram per second, and gram per second is what? Mass flow rate. That means mass flow rate is nothing, it's a density into material removal rate. So this is a mass flow rate, it is given. So sometime instead of material removal rate, it is in the unit, it is centimeter cube per second, it is not given, it is the unit, it is in gram per second. This is also MRR, but we have to multiply with the density. Okay, Aman, hi Aman. Now, so these are the density. So if you find this MRR, mass flow rate for this one, so mass flow rate is what? If you multiply with the density, so I into Z divided by F into N. So this is your mass flow rate. This is your mass flow rate. Clear? Now, what is the given data? In this question, what is the given data? The data it is given, there are two material, one is the iron, other was the metal P, and we have to find the fraction of, what is the fraction of metal P in this alloy. So, material, we will draw a table, material, then Z atomic weight, valency and alpha fraction. Why? Because they are asking the fraction. Okay, they are asking fraction. So my dear, material is first iron, and iron valency it is given 56, atomic weight, valency 2. Let's suppose its fraction is X in that alloy. In that alloy, X is the fraction of iron. Now, P, metal P. So, metal P, it is given 24 atomic weight, valency 4, and this is a fraction. So, fraction if you add equal to 1. So, this is what? 1 minus X. These are the given, this is given. So, first draw a table. First draw a table. Okay. This is a alpha is what? Fraction of the component. Fraction of the component. This is your fraction of the component. Okay. Also it is given current flow I. How much it is given, beta? 2000 ampere. This current it is given. Density of alloy it is given. That means combined iron plus P, it is given 6 gram per centimeter cube. It is given. And also the material removal rate is given is how much? This is given 50 mm cube per second volume flow rate. So, convert it is in centimeter. So, this is 50 cross 10 to the power minus 3 centimeter cube per second. Why? Because this density is in centimeter. So, we will convert this one in centimeter. Okay. Now, my dear, what is MRR? So, MRR, we know that current I into atomic weight divided by Faraday constant into density into valency. Clear? We have to write like that, I into Z by valency divided by F into rho. Clear? The MRR it is given 50 cross 10 to the power minus 3. Current it is given, beta, 2000. Z by N of the Ly we have to find. Why? Because Z individually know, valency individually we know. But Z by, this is for Ly. So, Z by N for Ly. This is for Ly. Okay. Now, Faraday constant it is given. It is given 96500 into density of Ly it is given 6 gram per centimeter cube. So, if you find here Z by N for Ly, if you solve, this is your 14.475. Now, we will reverse. Why we will reverse? We will discuss this thing while solving the problem. You have to find N by Z for Ly. So this is your value 0.069. So this is for Ly, my dear. Z by N by Z for Ly, we know that this thing. Now, how to calculate N by Z for Ly, different material? So my dear, for this material iron, we have to write N of iron, valency of iron divided by Z, like that. So we have to write this one. We have to write this quantity. N by Z for Ly, that is equal to summation of alpha I Ni divided by Zi. Different constituents. Okay. So alpha first N 2, so 2x for iron, and Z it is equal to 56 plus metal P 4 into 1 minus x divided by how much it is? 4 minus 24. 24. And this Ly it is given, my dear. This is equal to, this is how much? 0.069. 0.069. So from this expression we can easily calculate x value. So x is your approximately 0.745. We have to take like that, 0.75. So this is the fraction of iron will deposit it. Now we have to find the P for P. So P is how much? 1 minus x. So 1 minus 0.75. That means approximately 0.25. That means how much it is? 25%. How much it is? 25%. So what is the option? Option it is your 25. So they are saying that percentage of the metal P in the alloy, that is your 25. Correct na? Simple problem, but that is important thing. This is your important thing. How to calculate all the things. So we'll solve this again, the problem related to this thing, so you have a more confidence about that. Before going to the next problem, I have one announcement. What is that? See the announcement. This is your test series plus. So this is your plus. It is not only the test series, it is the added with something. What is that? In this one, if you join this test series, आपको ये सब बेनिफिट, ये सब सारे बेनिफिट्स आपको मिलेंगे. उसमें से क्या है? फर्स्ट बेनिफिट इज व्हाट? 130 प्लस ऑनलाइन टेस्ट सीरीज. आप 130 प्लस टेस्ट सीरीज को कर सकते हैं. उसके बाद आपको 33 ईयर गेट PYQ टेक्निकल सेपरेट एंड 33 ईयर गेट PYQ math and aptitude are separate. So there are two books. One is the technical book, other one is the math book, like that. This is the technical book. This is your technical, this is technical, this is technical. Along with that, there is an aptitude second book. Now you have also the benefit of the doubt solving portal. Okay. Now online revision and score booster, like that. You have access. Post gate guidance. Okay. And also the interview for the any PSUs or any competitive examination. Okay. For that one, अगर आप कुछ ज़्यादा जानने के इच्छुक हैं, if you know that more, in the link description it is given below in that channel. Okay. Now, so this is your link. Okay. Okay. Now, the second one is your, if you join IMS online program, this is the online program. So what is the program? features. 800 plus hour live classes with live interaction. It is not recording. All are the live classes. Second, आपको theory book and exercise book भी मिलेंगे. In the theory book, all the basics concepts are available. So don't bother about any textbook. If you read this theory book, that is a very good book. And also exercise book. What are the benefits in exercise book? The benefits of exercise book, there is 4,000 plus question is there. And all the questions are segregated by level 1, level 2 and level 3. Level 1 is the question related to the normal exam like PSUs, ISRO, state level, AEN, JEN. Level 2 in this exercise book, level 2 is exclusively dedicated for the GATE, and level 3 it is more than GATE. Okay. Now along with that we have आपको access मिली, this is 33. आपको 33 GATE questions banks मिलेंगे with a video solution. That is a very important. So जो questions bank मिलेंगे वो 2 parts होगा, technical and non-technical. Technical, that means core subject, and non-technical, that means mathematics and aptitude. There are 2 books. In that book, it is not only the solution, it is also provided the video solution of the best question, in which the जो student को problem होता है न्यूमेरिकल को सॉल्व करने में, कॉमन क्वेश्चंस होते हैं गेट में पूछा हुआ कि ये क्वेश्चंस हमेशा स्टूडेंट को प्रॉब्लम होता है या बहुत सारे कंफ्यूजन है, एनी प्लेटफॉर्म अगर आप देखें तो डिफरेंट सॉल्यूशन है, उस तरह के क्वेश्चंस का हमारे पास एक वीडियो सॉल्यूशन अवेलेबल होगा. उसमें QR कोड होंगे, जस्ट स्कैन इट एंड वॉच द वीडियो एंड आई डैम श्योर यू फील ए वेरी कंफर्टेबल फॉर दैट वन आफ्टर वॉचिंग दैट वीडियो. ओके. ऑल्सो वी हैव इट, आप बेनिफिटेड होंगे, आप प्रोग्राम फीचर्स में आप ये एक और बेनिफिट्स ऐड हो जाएगा उसमें 12 पर्सनलाइज 1-to-1 मेंटरशिप होता है. मेनी स्टूडेंट्स हेजिटेट while asking the question in the classroom. So there are 12 personalized 1-to-1 mentorship. You can book the sessions. The corresponding teacher will be in front of you and they will discuss whatever you want. Okay. And also there is 133 online test series, and only it is a set series. The solution we have to provide along with the video solution also. This is very important. Okay. If you want book for the free counseling, click the link in the description box, and also you can call when you feel very this is the mobile number, and we call anytime for that any further doubt. Okay. So these are the things update. Now we'll go to the problem. This is the second problem for the today. Just read the question. What is that, beta? The question is saying that calculate the material removal rate MRR in centimeter cube per second and the electrode feed rate. There are 2 questions. One is you are asking MRR in centimeter cube per second, and second feed rate F in mm per second. Okay. In the electrochemical machining ECM, okay, of iron surface, that is the this is what material removal rate, and itna the electrochemical machining of an iron surface, that is the surface, the workpiece, it is your 25 cross 25 mm in cross section, using sodium chloride NaCl water as electrolyte. So in that ACM we have used the electrolyte, so this is the NaCl. The gap between the tool, there is a tool in the electrochemical machining, there is a tool, and this is a workpiece. In between that there is a fluid. That means the workpiece will be inside the fluid. And what is the fluid? Fluid is NaCl water. So gap between the tool and the workpiece, it is given 0.25 mm. Generally we have to denote by, we are denoting by the H. And the supply voltage, the voltage, it is your V. What is the voltage you have to supply? The specific resistance of the electrolyte. This is the specific resistance, rho R, and it is given 3 ohm centimeter beta. It is not only resistance, this is a specific resistance. So if there is a specific resistance of any material it is given, so how to find the resistance, we will discuss this thing also. Valency it is given 2, atomic weight it is given 55.85, density it is given this much. Okay, again I will give you for a 1 minute and start this one. Just start. Read the question and then start. Okay, time's up. Now let's start this problem. So this is your how much? 25. Okay, the electrochemical machining of an iron surface that are, this is the tool cross section, the cross section of the tool. So this is your tool. This is your tool cross section. See, if you know the concept, then you have a very comfortable. आपको बहुत ज़्यादा comfortable feel होगा. Otherwise difficulty होगी. So that's why it is last. That means I hope जो इस बार के गेट एस्पिरेंट होंगे उन ये सब टॉपिक पढ़ लिए होंगे, तब जाके ये चीज को समझ में आएगी. So this is your 25 mm into 25 mm. Okay, so this is what? This is your tool area. Tool area. Tool area A. Now, there is a workpiece. There is a workpiece, my dear. There is a workpiece. And this workpiece and tool, this is a workpiece, is connected with a power source. Connected with a power source. Okay. And in this one, there is a electrolyte. This is your electrolyte. This is your electrolyte. So this electrolyte have a resistance. Let's suppose R is the resistance of this electrolyte, R. The gap it is given H. How much? The H is given 0.25 mm. This is H it is given. Okay. We have to provide a constant feed. So this is your feed. That means what is that, beta? If the machining is happening, so this gap is continuously reduced. Why? Because the surface is surface material is removed. So this gap will be increasing. So to maintain the gap, we always provide the feed on the tool. So we have always maintained this gap. Okay. So this is the direction of feed, tool feed. This is the direction of tool feed. Okay. And the voltage it is given. This is a current I. And this is a voltage V. And voltage V it is given beta how much? 12 volt. 12 volt it is given current. Okay. And this is your workpiece. Correct. So what is the cross section area of the tool? 25 cross 25, this is equal to 625 mm square. This is the cross section area of this tool. This area, cross section area of the tool, which is exposed to the, which is contact with the surface. This one, this area, bottom, which is contact with the fluid. Okay. Here, a specific resistance it is given. How much? 3 ohm centimeter. This is mm, so we convert 30 ohm mm. Okay. So if it is given, we can easily find the resistance R. What is this resistance? A specific resistance into gap divided by cross section area. Always remember, if the specific resistance it is given, how to calculate the resistance, that is okay. Now, so if you put this all value, then this is given 30 into gap, it is given 0.25 divided by cross section area is 625. If you calculate, that is your resistance is 0.012 ohm. This is your resistance, electrolyte resistance. Okay. Also given, what is given? Valence, atomic weight of this material, it is given 55.85, and valency it is given 2, density it is given 7.8 gram per centimeter cube. Yes, it is all the given value. Density it is equal to centimeter. This is centimeter. So 7860 kg per meter cube. So we have to write gram per centimeter cube. So 7.86 gram per centimeter cube. Okay. So from that one we can easily find current supply. V is equal, Ohm's law, V is equal to I into R. So from here we can easily find what is the current flow. So V is how much? 12 volt. R is how much? 0.012. So this value it is 1000 ampere. This is the current which is flowing inside the circuit. Now the next task is we have to find the material removal rate. So material removal rate, MRR. So material removal rate, MRR, material removal rate, MRR is equal to I into Z divided by F rho into N. I current 1000, valency it is how much? Atomic weight it is 55.85, Faraday constant 96500, density it is your 7.8 into valency it is how much? 2. If you calculate this value, it is your 0.037 centimeter cube per second. This is your material removal rate. This is your material removal rate. Now my dear, we have to calculate feed rate. Feed rate. How to calculate? Please think. Feed rate, what is the unit? Feed rate, mm per second. We have to calculate feed rate in mm per second. Okay. See my dear, just one arrangement. See, what is MRR here? What is the unit of MRR? Just balance the unit. MRR centimeter cube per second. So this is your centimeter, and we have to calculate mm. So this let's suppose this is your mm per second is equal to feed. Feed is how much? MRR mm per mm cube per second. This is centimeter cube, we have to take convert it into mm. So this is mm cube per second. So this is mm per second. Now my dear, we have to find mm cube per second. So this is mm multiply with the cross section area. So what is that? Mm. So this, see, the unit is balance, mm square, cross section area mm square. So mm cube per second. Now we'll convert this MRR into meter cube per second. We have to multiply with 10 to the power 3 centimeter, 10 to the power 3. So this is your 0.037 into 10 to the power 3. Now this is your mm cube per second is equal to feed rate into cross section area is 625 mm square. So the feed rate F is equal to 0.06 mm per second. My dear, in the gate, always very conscious with the unit. So 90% student stucks, वो रुक जाते हैं या उनको आंसर मैच नहीं कर पाता. क्यों? क्योंकि they have not arranged proper units. So proper units पे ध्यान रखना है आपको. proper units पे ध्यान रखना है. So अगर आपके पास MRR है तो बाकी सब अरेंजमेंट आप कर सकते हैं. If you have a MRR information, we can manipulate everything. Now, see my dear, second thing note down here. See, if you multiply MRR with density, that gives the mass flow rate. So density, you know, multiply with MRR, that is our mass flow rate. So sometimes they are asking the mass flow rate. So multiply with density, that is your mass flow rate. Cross section area, multiply with the feed, that is also MRR. So this thing is very clear. Okay. Now, done. Now we go to the next problem. See this thing. Electrochemical machining is performed to remove material from an iron surface. Okay. Remove material from an iron surface of 20 mm cross 20 mm under the following condition. Under the following condition. The inter-electrode gap, this value is H. This value is H, gap is H. Supply voltage is V. A specific resistance of the electrolyte, it is given. Atomic weight is Z. Valency N. Faraday constant F. The material removal rate, and my dear, this is your gram per second. Gram per second. So that means mass flow rate. So gram per second is equal to density into MRR. So first we have to calculate what is the value of MRR. Simple. What is the value of MRR? Okay. Again, I will provide you 1 minute. Okay. Time's up. This session is useful for particular who are जो appear हो रहे हैं गेट में प्रोडक्शन रिलेटेड. So this is the best way to revise. Okay. Now start this question again. Simple. Okay. So this is again there is a tool. Okay, iron tool, and this is a 20 mm. 20 mm. This is a tool. Okay, there is a workpiece. There is a workpiece. In between that, there is a electrolyte. This is the height H gap. This gap is how much it is given? 0.2 mm. See, 0.2 mm. This is your resistance of the electrolyte of the fluid. It will be, there is a power source. This is your power source. And this power source characteristic, it is given 12 volt. Here it is a flow of current I. Okay. Now, what is given? Specific resistance. It is given 2 ohm centimeter. So this is 20 ohm mm. Valency atomic weight, it is given 55.85. Valency, it is given 2. Faraday constant 96500. It is given coulomb per mole. Okay. So first step, find the resistance of that electrolyte, specific resistance into what? Specific resistance into gap H divided by cross section area. Don't forget. Okay, these are the common way. So specific resistance is your 20, gap it is your 0.2, cross section area it is your 20 into 20. So how much it is? This is your 0.01 ohm. These are the resistance. This is your resistance of the electrolyte. Now, we know that current V is equal to I into R. So from here we can easily find the current V by R. So I is equal to V is how much? 12. R is how much? 0.01. 0.01. So this is how much? 1200 ampere. So the current is okay. So these are the current. Once you have to find the current, this task is easy. So MRR is how much? I into Z divided by Faraday constant, density into valency. Okay. So if you multiply with MRR with density is equal to I into Z divided by F into N. It's okay. So this is your mass flow rate. Mass flow rate is equal to I into Z divided by Faraday constant into N. So this M, it is your gram per second. Okay, gram per second. Put this value I 1200, Z 55.85, Faraday constant 96500, valency it is your 2. So if you calculate this value, it is your 0.3741 gram per second. Simple problem, very simple. Okay, done. Very simple problem, my dear. Now Then we'll go to the next problem. Yes. Okay. Next problem. Next problem. Just read the question. Again, ECM, electrochemical machining operation are performed with tungsten as a tool. Here is a tungsten tool, and copper and aluminum as two different workpiece materials. So there is a tool is what? Tungsten, and that there are two workpiece of one is aluminum and other one is the copper. The property of copper and aluminum are given in table. Material copper, aluminum, atomic weight, that means this is Z. Z it is given. Atomic weight, that means Z it is given, my dear. This is your Z, valency N, density rho. So density it is given gram per centimeter cube. Density it is given. Okay. Atomic weight it is given, valency it is given, density it is given. Okay. Ignore over potential, that means excess potential you can ignore. Otherwise, over potential, there is a excess potential, it is value given. So what is the actual potential? We can subtract that. What is the voltage supply and what is the over potential voltage? Subtract, then we have to get the actual voltage. But here it is ignored. That means what is the voltage it is given, that is your actual voltage. Okay. Assume that the current efficiency is 100%. That means there is a current is 100% is there. Okay. For both workpiece material. Under the identical conditions, if the material removal rate of the copper it is given, this is nothing, this is mass flow rate, again it is given. Then the material removal rate of the aluminum. What is the material removal rate of the aluminum? Okay. Again, I will give you a timer for 1 minute. Just start with that. Okay. So I think this is your fourth question, है ना? Done. Time's up. So I think this is your fourth question. Yes. First done. Second, first done. Second done. Third done. Now this is your fourth question. Yes. This is your fourth question. Let's start this question. See. What is given? Material atomic weight, valency, density, and MMR is given in the form of MRR. It is given in the form of mass flow rate. Okay, the unit is same. First, draw a table so that there is a 0% of mistake. Now, material, first one is copper. Second one is aluminum. Okay. Now, valency, atomic weight is given 63. Change the color. 63. Okay. This is 63. It is given. Copper valency, atomic weight 27. Valency it is 2. This is 3. Density it is 9. This is your 2.7. And material removal rate of copper it is given 100. gram per second. Let's suppose this is your x gram per second. We have to find this value. Okay. So we know that MRR into density is equal to mass flow rate. We know this thing. MRR into density is equal to mass flow rate. So first task is to calculate MRR, material removal rate. Same formula, MRR is equal to current atomic weight divided by Faraday constant into density into valency. Now first for copper, MRR it is given how much? 100. Yes or not? 100 it is given. This is milligram, not gram. See, very important. This is your MRR given milligram per second. This is not gram, milligram. So this is a milligram. Milligram it is given. So here, so MRR convert into gram. So 100 cross 10 to the power minus 3 gram per second is equal to density. We have to multiply in this one. Current is how much? Current it is given or not? Material removal rate, 1 second. So current it is not given. Yes, current it is not given. So current I into atomic weight for copper it is given 63 into Faraday constant 96500 and copper valency is 2. Now my dear, this unit it is your gram per centimeter, na? Gram per second. Okay, gram per second. So directly it is multiplied with MRR into density. So we are not here putting the density value. So in this one, what is the current then? The current it is your 306.35 ampere. This is your current. Now they are giving that current efficiency is 100%. That means ignore and assume that the current efficiency is 100% for both workpiece material. That means what is the current you have to find. हमने क्या current copper material के समय जो current while you calculating the current operation of the that means electrochemical machining on the copper material. So what is the current? Is the same current you have to use when we have to calculating the MRR for the aluminum. Why? Because the current efficiency is 100% for both. There is nothing will change. That means what is the current for that material copper? The same current for the material aluminum. That means you find the you can have a knowledge about the current. Okay. Then since the current efficiency is equal to 100% for both copper and aluminum. Now for aluminum, okay. So MRR into density, that is nothing, mass flow rate, and that is equal to I into Z divided by F into N. So I is your 306.35 and the aluminum valency, it is your aluminum atomic weight 27. 27, Faraday constant 96500 into valency, it is how much? 3. 3 is the valency, na? Copper valency 3. So if you put this value, the material removal rate of aluminum, if you calculate this value, this is your 0.02528 0.02857 gram per second, but they are asking in the milligram per second. So this is your 28.57 milligram per second. This is the material removal rate of aluminum. This is the material removal rate of aluminum. Correct? This is the material removal rate of aluminum. Done? Done na? Now, there is also next problem is here. And that is this problem. Okay. Okay. So I will read the question first. What is that? The surface irregularities of electrodes use an electrochemical machining (ECM) process are 3 micrometer and 6 micrometer. Microns, 3 microns and 6 microns. See the figure. There is a machining will takes place, and there is a surface roughness. Average value is your 0.6 micrometer, and this is 3 micrometer. Okay, this is surface number. So what is the total depth? Is 9 micron. Total depth is 9 micron. So the gap it is given. Okay, this is a tool, and there is a workpiece. So the gap is how much? Total gap is how much? This total gap is how much? 6 plus this 3. That is your gap. This gap. This is 6. So this is the gap, average gap. Yes or not? 6 plus. So this is 6, and this is the 3. So gap is how much? 9. Okay. Done. So the surface irregularity, it is given as shown in figure. If the workpiece is of pure iron, workpiece is your pure iron, and we have to supply 12 volt between the electrodes, is applied between the electrode. The largest feed rate, what is the largest feed rate? In mm per minute. That is also mass flow rate. This is mm per minute. That means feed rate. This is not discharge. This is your not material removal rate. This is your feed rate F. And the condition it is given, conductivity of the electrolyte. This is the conductivity. So what is the relation between the conductivity and the specific resistance? We will discuss. And this is given 0.02 ohm per 0.02 per ohm mm. See here, over potential voltage is given, that means excess potential. So this is 1.5 volt. So what is the actual voltage? 12 minus 1.5 volt is the actual voltage. Okay. Density it is given kg per meter cube. Okay. Atomic weight it is given 55.85 gram. Right. Assume the iron to be a dissolution as Fe plus 2. Plus 2. 2 is what? Valency. Okay, this 2 is your valency, and the Faraday constant it is given 96500 coulomb per mole. Okay, so we are asking they are asking that feed rate in mm per minute is what? Mm per minute is what? Okay, so again I will provide you for 1 minute time. कहाँ रखो इसको, यहाँ रखो। Time's up. Okay, so these are the tool and this is the workpiece. Gap, it is your 9 microns. Okay, and this is your conductivity of the electrolyte. Conductivity it is given. Okay, so see, this is the tape chart and this is your tool gap. So in this, see my dear, if you carefully observe, this is your conductivity and the unit of conductivity is 0.2 per ohm mm, right? What is the unit of specific resistance? Ohm mm. Yes or no? This is your specific resistance. Specific resistance of the electrolyte. So see, it is just inverse. So specific resistance is what? 1 by conductivity. This is important. Specific resistance is 1 by conductivity. Clear? And what is the specific resistance? What is the specific resistance? So what is the total resistance? R. Similarly, specific resistance into gap divided by cross section area. Yes or not? From this one, you can easily find what is the resistance of the electrolyte. Okay. And this is your ohm. It is in ohm. Okay. So write some note. Why? Because student here confused. I know that. Note. What is that? A specific resistance, or you can also say that resistivity. Both are the same thing. This is rho r and this is your 1 by conductivity. 1 by conductivity. Both are the same thing. Clear? Both are the same thing. Okay? Specific resistance or resistivity. Both are the same thing. And these are the inversely proportional of the conductivity. Okay? Now, what is the gap here? It is given. The gap, it is your 6 plus 3, that means 9 micrometer. So this is your 0.009 mm. 0.009 mm. And here beta, over potential voltage it is given 1.2 volt. So what is the actual voltage which is supplying? 12 minus 1.2. So this is your 10.8 volt. Yes or not? 10.8 volt. This is how much? 10.8. How much it is? 12. So this is 1.5, I think. Yes. This is 1.5 it is given, not 1.2. 1.5. So this is your 10.5. 10.5. Clear now? So this is a voltage we have. gap we have. From here we can easily find the resistance. So how to find the resistance then? The resistance, why? Because cross section area it is not given beta. So the resistance is equal to, resistivity is equal to 1 by conduction. The conductivity is 0.25. So here what is the resistivity? R. 1 by 0.02, that is your 50 ohm mm. Okay, 50 ohm mm. So we have to find the resistance R, resistivity into electrode gap divided by cross section area. So what is the resistance? 50 resistance we have to find it. Resistivity is 50, height is 0.009 divided by cross section area. That's it. This is your resistance of the electrolyte. Okay. Now, what is MRR? MRR is what beta? I into Z divided by F into rho into N. Now, they are asking that, what are they asking? Feed rate. Feed. Again, what is the relation then? So, very first we already know that what is the feed rate. See, this is the feed rate. MRR is feed rate into cross section area. Same problem. So, feed rate, see, this is what unit? This is what unit beta? MRR. See, this MRR, it is the unit, that one in the form of gram. It is in the form of gram. So, if you put this value all, MRR, current we have, how much current supplying? Current, oh, we don't have a current. First we have to find the current. Why? Because voltage is there, R is there. So, first find the current. So, current V is equal to I into R. So, here I is equal to V by R. So, I, what is V? 10.5. What is R? 50 into 0.09 divided by cross section area. Okay. So, from here I value it is 23, if you solve this one, 23.33 into cross section area. This is your I value, I. Okay. So, I it is equal to 23.33 into cross section area into Z. Z value it is given 55.85 divided by Faraday constant 96500. Density it is given beta, and this density it is given 7 kg per meter cube. So, we have to convert into gram per mm cube. So, this is what? 7.86. This is your kg na. So, we have to convert, it is your mm. So, kg 10 to the power 3. This is your kg what? 10 to the power 3. We convert into this. So, kg what? 10 to the 3, that means gram. We convert m into mm. So, this is what? 100. So, 100 by power 10 to the power 3 is 6. This is your 10 to the power 6 minus 6. Yes or not? This is your 100. This is your 100. 1 meter. So, mm converted into 1000. So, this is your 10 to the power, that means 10 to the power 9. This is 10 to the power 9 mm cube. So, 10 to the power 9 mm cube, and nominator it is your 10 to the power 3. So this is what 7860 into 10 to the power minus 6 gram per mm cube. So this is equivalent to 7860 into 10 to the power minus 6 gram per mm cube. Gram per mm cube. So we have to write here 7860 into 10 to the power minus 6. Now you have to solve this value. It is in the function of cross section area. This is your function of cross section area, beta. Yes or no? Now, this is a function of cross section. Now, my dear, if you multiply, we know that if you multiply MRR is equal to feed into cross section area. Yes or not? Feed into cross section area. So MRR divided by cross section area is equal to feed. So if you divide this one, MRR divided by the cross section area, that is what? That is what, my dear? This is your feed. This is your feed. So remove this cross section area. So if you calculate this value, it is 0.89859, 0.859 mm per second. But the question they are asking that, very important, unit is very, the question they are asking that mm per minute. This is mm per second, not mm per minute. So we'll convert, it is your, so this is your 51.54 mm per minute. This is your feed rate. Yani in 1 minute, what is the meaning? In 1 minute, the tool will traveled, that means approach to the workpiece 51.54 mm, like that. Okay, so this is your feed, like that. This is the feed rate. This is not a feed, this is your feed rate. So this feed rate, mm per minute, these are the feed rate. So you are giving this constant. Why we are giving this feed rate? Why? Because you maintain the constant gap. That means if your machining is there, so material will deposited, material will be removed on the workpiece. So there is a gap will increase. So constantly you are giving the feed on the tool so that the gap will maintain. So this is the speed of the tool in the form of feed, 51.54 mm per minute. Clear? This thing is clear, beta? Okay. So now these are the some question related to the non-traditional machining या unconventional machining. Okay, these are the latest machining process. Okay, now we'll start the second phase, that is your metal forming. Okay, metal forming, we'll be discussing the metal forming. Okay, so what is the first question? See, yes, this is the basic question. We'll start from this one. So a metal rod is, this is a very important question, I'm telling you. A metal rod is elongated by 24.6%. Which process? By tensile, UTM machine, universal testing machine. So in the universal testing machine, if you draw the stress and strain diagram, so strain is what? Engineering strain. Strain in what? Engineering strain. So this is your engineering strain, it is given. Okay. If the material behavior is given by, these are the flow curve equation, it is given. Flow curve, this is your strength coefficient, material strength coefficient. 250 is the material strength coefficient. Ipsila is your true strain. 0.2 is your exponent hardening component. This is your exponent. This is a this 0.2 is your strain hardening coefficient. So this 250 sometime it is denoted by K, and that is your work strength coefficient, material strength coefficient, that strength coefficient, and this epsilon is your true strain, and this 0.2 denoted by n, that means strain hardening exponent. Strain hardening exponent. Strain hardening exponent, and this equation sigma is equal to 250 epsilon to power 0.2. This is in the form of this one. Sigma f is equal to k epsilon to power n. And this is your flow curve equation. What is called? Flow curve equation during the plastic deformation zone. This is the plastic power law. In this one there is a power law. Let's suppose this is your stress strain curve. Stress and strain curve. So it is like that. So in this one, it is follow the power law curve. This is ultimate tensile strength. This is yield strength. So in this one, there is a elastic zone. So we are calculating with the stress directly proportional to strain. But these are the material of the deformation. So we are going to the plastic zone. So the plastic zone, this is the equation. Sigma f is equal to k true strain hardening. This given. It is given. This is called flow curve equation. What is again? Flow curve equation. It is given. Flow curve equation. First, find the average stress required for this deformation. Average stress. That means, what is the average stress? Mean flow stress. What is that? Mean flow. And how to denote? This is sigma f bar or sigma f m. These are the notation. So this is a flow stress. And what is the mean flow stress for this deformation? Second, what is the yield strength of this material? Third, flow stress of the material. Flow stress, that means this. This is a flow stress and this is a mean flow stress. So first, we have to calculate the flow stress. Second, we have to calculate the mean flow stress. Third, yield strength of the material. Okay. I will give you again a time for 1 minute. Done. Okay, now start. Okay, so here due to tensile tensile deformation, that means engineering strain, this is a true strain, engineering strain, that means E it is given how much 20 4.6%, that means 0.246%, 6.246. Okay, this is your engineering strain is given. So from the engineering strain it is given how to find true strain. How to find true strain, beta? Why we are working in true strain? Why? Because there is a plastic deformation, and plastic deformation, this true strain is higher than at the ultimate point. This true strain is higher than it will be separate from the yield point, and it true strain at corresponding to the ultimate point will be higher than the engineering strain. Okay. So what is the true strain? ln 1 plus E. It will be derived. ये derived होता है, आपको पता होगा, आपको अगर रिवीजन कर रहे होंगे तो. So ln 1 plus E 0.246. So this is how much? This is your 0.2. So this is your true strain. So true stress is higher than the engineering stress. True strain is little bit less. Okay, it is like that, my dear. See, stress and strain. This is your engineering, and this is your true. This is your true. This is your true. See, the stress is higher corresponding to the. This is your UTM corresponding to UTM, universal test UTM, ultimate tensile strength UTS. Corresponding to UTS. So corresponding to UTS, the stress, engineering stress is higher than the true stress. This is true stress is higher than the engineering stress. Okay. Now, so this is true strain. First part, find the. They are now asking the true strain. Find the average. Okay. What is the yield, and then the final the flow stress of the material. Now. So flow stress, just we have to find this is a true strain, so we can easily find the flow stress. So flow stress is what? Sigma F is equal to K epsilon. This is true by power n. Now this flow stress K strength coefficient is how much? 250. Epsilon is how much? True strain 0.22. Strength coefficient is how much? Strength the strain hardening exponent 0.2. So if we calculate this value, it is 184 megapascal. So this is what, beta? Flow stress. Flow stress. So 184 is the flow stress. So this is the flow stress. 184 is the flow stress. Is the flow stress. Now we have to calculate the average stress. So once we have a flow stress, how to calculate average stress? That is the method. What is that? And always remember this thing. See, if your value of flow stress equation, and that is your strength coefficient, true strain, strain hardening exponent, it is given like that, n. This is given. So how to find from this equation, how to find mean flow stress or average stress? So we have to find this one with integration 0 to epsilon. Let's suppose there is a flow stress into very small strain divided by total strain. This is the method to calculating the average, statistical method, and this concept will be used in anywhere. If you calculate the average heat transfer coefficient, if you calculate the average Nusselt number, if you calculate all the things, average velocity, if you calculate the average discharge, if you calculate there is a varying velocity profile, so how to calculate average, this is also this thing. Okay, so this is always remember. So flow stress, it is given. If you put this value, solve it, So the average stress, it is your K epsilon power n divided by n plus 1. If you solve this integration, and this is what? Flow stress divided by n plus 1. This is the relation between the average stress and the flow stress. Okay. So second part is your average stress. So flow stress is how much? Already calculate flow stress 184 megapascal divided by 0.2, n is 0.2, so 1.2. How much it is? 153.9, that means approximately 154. 154 megapascal. This is your average stress. This is your average stress. Now, once you have a stress, and then the next part is very important. I am telling you, this part is very important. See, that's a simple thing is that how to calculate the flow stress and how to calculate the average flow stress. That is the simple thing. But this have a concept. What is that? How to find what is the yield strength of the material? What is the yield strength of the material? So to find yield strength of the material, simple thing beta. Yield strength, that means to find yield strength and the deformation. This is your to find what is that beta? Deformation. And where is the deformation? There must be a shear stress. Without shear stress, the material cannot deform. See, the material, let's suppose the material is fluid. So how the fluid will deform? The help of shear stress. So there is a deformation, there must be shear stress. So here we have to find yield strength. So SYS, this is your yield strength in shear. Yield strength in shear. My dear, this is what is the difference between the strength and stress? Anyone? What is the difference between stress and strength? You know, what is the difference between stress and strength? My dear, strength is a material property. Yield strength, ultimate strength, fracture strength, these are the strength, and this will be vary from material to material. But the stress is not a material property. Okay. So yield strength. Let's suppose this is our material. Let's suppose this is our material. Stress versus strain. And let's suppose it is like that. There is any material. So if we have like that, how to find the strain corresponding to the yield stress? So let's suppose there is any point, there is a yielding will take place. At this point there is a yielding. This is the point of yielding. So corresponding yielding, what is the strain? This will be done by the offset method. So what is that? We have to draw a tangent from this one. This is your tangent. Now take a roller and take this tangent parallel to this line intersecting, and where it will be intersect, that is your strain, and this is experimentally 0.02. This is from the offset method. How to find offset method? So this is your strain. So if you find what is the flow curve, this is the flow curve. So if you find yield strength in shear, That is your flow. K is your how much? K is how much, my dear? K is your 250. 250. Now strain is how much then? 0.02. Exponent is same, that is 0.2, I think. Exponent is 0.2. 0.2. If you solve this value, this is your 72.13. So this is your yield strength in shear. This is your yield strength. So this is the question. What is the yield shear of the material? That is what. So see, if you compare the result, my dear, if you compare the result, what is the flow stress? Flow stress, it is your 184 megapascal. Mean flow stress, it is your averaging, and that is your 154 megapascal. 154 megapascal. Yield shear strength, in shear, it is your 72.13. See. So these are the decreasing order. Clear? So if you have a flow curve equation, you can easily find the mean flow stress. If you have a mean flow stress, if you have this curve flow stress, you can find mean flow stress. If you have a flow stress, you can easily find the yield strength from the method of offset method. Okay? Done? Done now? Okay? Now, so these are the things. Now next problem. Yes, this is the next problem. It is visible. Yes, it is visible. So I will read this question. A cylindrical billet of 100 mm diameter and 100 mm length is extruded by a direct extrusion process. There is a direct extrusion, that means forward, to produce a bar of L section. The graph it is given L section. The next page it is there. See. Oh, this is your L section. Yes or not? This is your L section. Okay, this is your L section. It is producing like that. One second, my dear. One second. Take. It is like that, beta. Yes, it is like that. There is a billet container and we have to press it. There is a extruded portion. Okay. So L section it is given. This is your L section. It will produce in this form of that one. Okay. So L section, cross section of the dimension of the L section of the bar as shown in figure, the dimension given hai. The total extrusion pressure P in megapascal for the above process is related to the extrusion ratio as. This is a total pressure, it is given in the question, it is given. Ks is your, Ks is what? Ks is your die shape factor. This is your die shape factor Ks. Sigma m is the mean flow stress. 0.8 plus 1.5 ln. R is your extrusion ratio plus 2 L is the length of the billet and DO is the initial diameter of the billet. This is given. Sigma m is the mean flow strength of the billet material in the megapascal, it is given. L is the portion of the billet length remain to the extruded in mm. What is that? In the chamber, die chamber. D naught is the initial diameter of the billet in mm. Ks is the die shape factor. Ks is what? Die shape factor. This is important. Die shape factor. And die shape factor, it is given, beta. Factor. It is given. See, die shape factor is 1.05. Then the mean, if the mean flow strength of the material, it is given also 50 megapascal. So maximum force required to start the extrusion in kilonewton. Maximum force. They are asking that maximum force. So I will again give you for 1 minute. Just start. Time up. Okay. So this is our L shape. Now, so my dear, what is your direct extrusion process? In this one, there is a direct extrusion. Direct extrusion process. What is that direct extrusion process? Little bit. That means extruded part comes into the same direction, comes into the same direction as that of piston movement. Yeah, ram movement. So what is the ram movement? It is a pushing kind. So during the pushing, both are the pushing. So in this one, there is a pushing kind of the force. Compressive nature of the force will exerted in the extrusion. So during the pushing, what is the motion of the piston? What is the direction of the motion of the pistons? What is the direction of the motion of the piston? Same direction the extrusion will move. Extruded part will move. That is your. Is also called forward extrusion. Yeah, direct extrusion. Okay. So what is that, beta? See, this is your chamber, my dear. This is your chamber. Okay. This is your chamber, and this is your die. This is your die. This is your extrusion portion, extruded portion. let's suppose, and this is your billet. This is your billet, and there is a piston like a plunger, also called ram. It will be pushed like that. So this billet will move out from this one. So this is your die. This is your die. This is your billet. This is your billet, and this is your ram, plunger. Now, my dear, it is given that the cylindrical billet of 10 mm into 10 mm length. So this is 10 mm, 100 mm, and this is also 100 mm cylindrical billet. 100 mm into 100 mm is the cylindrical billet. Now, my dear, in this forward extrusion, we required more pressure, more load, more ram pressure as compared to the backward extrusion. Why? The forward extrusion, the requirement of force is more as compared to the backward extrusion. Why? Why? Because in the direct extrusion process, the friction will oppose the applied load. Why? Because see, if let's suppose we'll write like that, okay. So we apply the force here. Let's suppose we apply the force here. So material will flow like that. Yes or not? Material will flow like that. We'll apply the pressure. But between this container, this chamber and the material, there is a friction in this direction. On the container, there is a friction. So to compensate this friction, beta, we have applied the more effort on it. So this is friction. Friction. Due to this, additional pressure is required. Due to this, additional pressure will required. Additional pressure will required. Now, my dear, this material will flow. So there is extruded pressure is there to flow the material, but also we have to require little bit more to compensate this friction also. So there is a more effort is required in the direct extrusion. Okay. So the total pressure, how much required? Let's suppose, so this is drawing pressure plus pressure due to the friction. This is the total required. If the friction value is given, so this is what? Pressure required to deform the material into the die. Yes or not? Into the die. Clear now? Now, how to find this additional pressure required due to the friction? Very important. How to find? Please tell me. For this one, we have a direct relation. Yeah, in the question it is provided, no problem. Like that, see, it is provided. This is for sigma d, direct. sigma d. But how to find this additional pressure required which is due to the friction? How to find? So, one second. Here we have to find, no problem. So, to find this F, that means additional pressure required due to friction. Why? Because in this case friction will oppose. Let's suppose there is a example, plane strain condition. Plane strain condition. So, during the plane strain condition, we know that yield strength in shear is equal to flow stress divided by root 3. This is from the, how we'll get these things? What do we go? MSST, maximum shear stress theory. This is according to maximum shear stress theory in MD. So, this sigma F multiplied by cross section area pi by 4 initial diameter dO square. So, this is the force due to this friction is equal to, this is a deformation shear tau ys, and the shear, let's suppose, see my dear, this is your billet, okay, and this billet is moving this direction. So, in this direction there is a shear stress. So, this is your all the periphery. Let's suppose this is your cylinder. So, if it is moving like that, see, if it is moving like that, understood? If it is moving like that, so over the periphery, the opposite direction, there must be a shear stress. So, this, if you calculate the shear force, so pi d into L. L is the length of the billet, D is the dia of the billet, initial dia, mind it, this is initial dia, after exclusion nahi. So, initial dia, di, here must be di, initial dia, here it is also initial dia, do, instead of do we can write initial dia, di, and this flow will, this pressure will exert over it. So, this pressure will exert. So, this is your drawing pressure, sigma d. So, over the cross section, this is your cross section. So, this is pressure over the cross section of this cross section. Okay. From here, we can easily find additional force, yeah, pressure required. This is the important thing. Why? Because it right now in the gate, मतलब ये गेट में अभी तक पूछा नहीं गया है, लेकिन क्या हो सकता है इस बार आ जाए. So don't ignore this thing. Okay. Now let's come to the problem. So this is your final product. This is your final product, my dear. Yeah, extruded part. This is your extruded portion. Yeah, extruded cross section. This is your extruded cross section. And initially it is a cylinder. So initially it is cylinder. Now you apply the pressure. So this is final outcome. Okay. Now my dear, the extrusion pressure it is given. Extrusion pressure it is given. Extrusion pressure it is given P. You can D also write down PD, and it is given empirical relation Ks into flow stress, mean flow into mean flow stress into 0.8 plus ln, R is your extrusion ratio, plus this is plus na, yes, plus 2L length of this billet divided by initial diameter di. Okay. Now here my dear, this Ks is your die shape factor. And it is given 1.05. It is given in the question. This is your mean flow stress. And it is given in the question or not? Please tell me. Yes, the mean flow stress it is given 50 megapascal. And this is your extrusion ratio. We have to calculate, no problem. Okay. So my dear, so extrusion ratio is the ratio of area. That means this extrusion ratio, it is your initial area divided by final area. So these are the final cross section. These are the extruded cross section. That means this is a final cross section. So what is the final cross section then? Let's suppose, how to calculate this cross section? Simple, my dear, very simple. So this is how much? These are 10. So these are 50. Yes or not? 50 mm. So this plus this. Yes or not? This is our final. So the final area is equal to 10 into 50 plus 50 into 10, yes or not? Right. 50 into 10 plus 50 into 10. So this is how much? 1000 mm square. This is a final area. And what is the initial area, beta? Initial area. So initially it is a billet. What is the initial area of this one? What is the initial area? So this is your initial area. So from this one, what is the initial area? Pi by 4. This pi by 4, why goes cylindrical? Pi by 4 d initial square. This is your initial area. So initial area pi by 4 d initial square. So pi by 4 and initial diameter, how much it is given? 100 mm. So 100 square. So this is how much? 7853.98 mm square. So this is your initial area and this is your final area of this product. So what is the extrusion ratio? R initial area by final area. My dear, always extrusion ratio is greater than 1. Always take higher by lower. Always. So AI is what? 7853.98 divided by 1000. So this extrusion ratio is how much? 7.853. 7.853. This is your R value, extrusion ratio. Once you have extrusion ratio, all the value you have, put this value. So this is your drawing. Put all this value here. So drawing stress is equal to, what is that, Ks into average flow stress, it is given, into 0.8 plus 1.5 ln R plus 2L by initial dia. Okay, put all this value. Die shape factor it is given. Die shape factor how much? Die shape factor it is given 1.05. Flow stress it is given 50. 0.8 plus 1.5 ln. Extrusion ratio how much beta? Extrusion ratio 7.853. 7.853 plus 2. Length of the billet is 100. Initial diameter is also 100. So if you calculate this value, it is your 309.296 megapascal. So this is your drawing load, drawing pressure. This is your drawing pressure. Yeah, extrusion pressure. This is your pressure exerted by the ram on the billet. On the billet. Okay. So what is the force? Force required. What is the force required, my dear? Force required F is equal to this drawing pressure, drawing force it is, drawing pressure into which area? Initial area, pi by 4 di. Why? Because on this area the force is applied. So drawing stress, it is your 309.296 into pi by 4 into 100 square. So this is how much? If you calculate, this is your 2429.78 kilo. Clear? Clear? Clear, my dear? Done na? So like that we can solve this problem. Okay? So that is done. Now we take one note point here. See, my dear, this is the expression it is given. This one, this is the expression it is given. So in the extrusion beta, there is a two method. One is the Johnson equation it is given, or other one is the plane strain equation. Plane strain equation. That means if you write a note, my dear, note, either backward or forward. Forward or backward extrusion, both are same. Both have a same formula. So the extrusion pressure is equal to mean flow stress into 1 plus beta divided by beta into initial area by final area पे power beta minus 1. This is for the case of plane strain case. This is for the plane strain case. My dear, all the things are same. If there is a wire drawing, just reverse. That means 1 minus AI by AF. Here, beta is equal to mu cot alpha. Alpha is your semi-diangle. Alpha is what, beta? Alpha is your diangle, semi-diangle. Mu is what? Coefficient of friction. Coefficient of friction. So this is your formula. Okay. So first find beta, then AIAF, all the things are same. Now, this is what mean flow stress, beta. And mean flow stress have a different. If you calculate the mean flow stress, in the question there are three situations it is given, beta. In the question there are three situations it is given. In the question there are three situations given. Let's suppose, matlab three type of situation in the question it may be possible to calculate. Let's suppose there is yield strength is given. Yield strength. It is given. That means sigma ys. So this is directly you can put as a mean stress. If it is a both given, yield strength is given and also ultimate strength is given, beta. Both it is given. So if you find the mean stress, just average divided by 2. Now there may be a flow equation it is given, sigma f k epsilon pe power n. It is given like that. So either it is given only yield strength. So what is the yield strength? That is your mean flow stress. If it is given ultimate and yield strength, so find the average, that is your mean flow stress. If it is a flow curve equation is given, so we know that from this one how to find mean stress? Sigma f divided by n plus 1. So these are the four case possibility. Three possibilities there. Okay, so from this one we can easily calculate the mean strength value. Mean strength value we can easily calculate. Done. So every aspect, हर एक डोमेन से हमने इसको क्लियर किया क्वेश्चन को. The question is very easy, no problem. But the question is such a large sentence is there. See, large lining there. 1, 2, 3. How much the long question is that? So student they are afraid. मतलब question को देखते ही वो डर जाते. डरना नहीं है. Just take your time. This question for 2 minutes and very few people can solve. So it is better to read this question and take a time for 1 minute. Automatically all the things will clear. Okay. Now next problem. Yes, next problem. A 4 mm thick aluminum sheet of width 100 mm is rolled into two roll mill of roller diameter 200 mm each. The workpiece is lubricated with a mineral oil which gives a coefficient of friction 0.1. The flow stress of the material is, this is equation of the flow stress. See, it is given in the form of equation. So in the form of equation it is given. If you use this formula, sir, if you calculate mean flow stress sigma f divided by n plus 1. Now, how to find this then? You cannot find for this formula. Why? Because this is applicable. This is applicable when it is in the form of this k epsilon pe power n. When then this formula is applicable. But it is in this form, my dear. It is in this form. So it's my humble request that if you find the mean flow stress, just take 1 by E 0 to E sigma f dE. Always go to this formula. So here you can find. Why? Because sigma f, it is equation form, it is given. Okay. So that, for that one, this question is unique. Okay. Now my dear, where ipsila, where ipsila is a true strain, assume the rolling to be a plane strain deformation. Yes, process. Plane strain deformation process. The roll suppressing force for the maximum possible draft thickness. That means delta H max. Maximum हमें thickness को reduce करना है during the rolling process. So how much the force is required? That means separating force on the roller. How much the force will act on the roller? And see, this equation it is given. This force equation it is given. What is that, beta? Where, see, this is your average flow stress, it is given. So how to find this value? First find this one. Okay. L is the roll workpiece contact length, length of contact in the roller, and W is the width, and there is a H bar. H bar is the average sheet thickness, initial plus final divided by 2. So what is H bar? Average plate thickness, initial thickness plus final thickness divided by 2. My dear, first we have to calculate this value, then this value, then we have to put and find the F. Then how to, here beta, it is not given what is that initial diameter, initial height, and what is the final height. It is not given in the question. Initial height it is given or not, please check it. (100 mm). 4 mm thick element. This initial height it is given, HI. But here my dear, the final height is not given. The final height is not given. So we have to first find final height, then we have to find H average, then we have to find the mean, then we have to put the value. Simple, in between the steps is there. Okay. So again I will give you 1 minute and try to solve it. Time's up. So beta, in the metal forming, there are two methods to calculate the forces. First is your plane strain condition, and second is your Johnson formula. Okay. So let's see this problem. See, this is your plate. This is your plate, and this plate it is given height HI, and that is your 4 mm, and this plate width it is given, that is your 100 mm, and it will be going into the roller. So its height will reduce, maximum height will reduce. So what is that height? We will discuss this thing. Now, so what is the maximum draft? delta H max, that is your HI, initial height obviously larger as after the rolling, that means this height will reduce, HF. Now my dear, there is a draft maximum reduction. Now as we know that from the rolling formula, the maximum reduction draft is equal to mu square into radius of roll. If you know, then you can solve, otherwise very difficult. Okay. Now coefficient of friction, it is given 0.1 square, radius of roll it is given 100, yes, diameter it is given 200 diameter, so radius is 100, is equal to H initial is 4 mm minus H final. So very first thing is that we have to calculate the final, and this final it is your 3 mm. What is that? 3 mm. The final it is your 3 mm. What is the final height? 3 mm. Okay. So once you have to available the final height, we can easily find what is the average. H initial plus H final divided by 2. H initial is how much? 4 plus 3 divided by 2, that means 3.5 mm. So all the calculation during the rolling operation, we take this height average. Okay. Now what is the rolling separating force? It is given. It is given. Na? So in that one there is a mean stress. That one there is a mean stress. So how to find the mean stress? Just see. So mean stress, flow stress is equal to 1 by epsilon 0 to epsilon flow stress into d epsilon. Now 1 by epsilon 0 to epsilon, what is the flow curve equation? 207 plus 414 epsilon into d epsilon. Yes or no? Now we have to solve this one. So 1 by epsilon, this is your 204 epsilon plus this is your 414 epsilon square by 2. This is like that. So my dear, from here the average flow stress is equal to this is 204 plus divide by 2, 204 1 epsilon into epsilon. Now this is what? This is true strain. True strain. Now how to find then true strain? Then we have to find the average. So true strain you have to find ln, true strain ln final initial hi by higher by lower, always take higher by lower, hf. So ln hi is 4, hf is your 3. So this is your how much? This is your approximately 0.2876. Now from here we can easily put from this equation flow stress 204 plus 204 into 0.2876. If you solve, this value will come out to be 266.5332 megapascal. Now done. Now this is no problem. Now my dear, this is done. This is the main part of calculation. Now if you apply this force, there is your length of contact. So how to find this length of contact in the rolling operation? L length of contact is equal to a square root of R into delta H. What is that? R into delta H. Okay? R into delta H. So my dear, R is how much? 100. Delta H is equal to H final minus H initial minus H final. H initial is 4, H final is 3. So this is 1. So if we calculate this, contact length is equal to 10 mm. All the things I have. Now in this question, the force it is given, rolling separating force it is given. F is equal to, this F it is given beta, F is equal to 1.15 average stress into 1 plus mu length of contact divided by 2h into width into length, that means length of contact. So always calculate on the basis of length of contact. So put this value here, 1.15. What is the average stress? Average stress is your 266.5323. 266.5323. Yes or no? 5332. 5332. 5332. This is your average stress into 1 plus mu 0.1. Length of contact is how much? Length of contact, it is your 10 mm. So 10 divided by 2 into h bar is 3.5. Width is your 100, I think. Width is your 100. Width is 100. Length of contact again 10. Solve this equation, putting value, this is your 351 kilo Newton. Simple. Simple beta. This is your simple thing, okay? So how to calculate? So my dear, don't remember this formula, that means the lengthy formula, big one formula. All the formula it is given. How to calculate the entire data inside the formula, that is the important thing. That is your important thing. Clear? This thing is clear now? So the catch is here. We have to integrate it, otherwise very difficult. Now, we'll take the next problem. Yes. See this thing? This is also simple. Read this question. The thickness of the steel plate with a material strength coefficient, that means my dear, K value, has to reduce from 20 to 15 mm. 20 is HI, 15 is HF, in the single pass of 2 high roll mill, single pass, okay, with a rolling radius, this is not a diameter, this is radius it is given, and the rolling velocity, it is given, V of roll. If the plate has a width of, this is your B, and its strain hardening exponent, this is your N, the rolling force required for this operation in kilonewton, okay, it is not necessary. This is not necessary, not required. In the question, it is not required. We will know this thing. We know this thing. We know. Okay. Again, I will give you 1 minute. Start this problem. Start. डन। चलिए इसको स्टार्ट करते हैं। सिंपल प्रॉब्लम, ये भी बहुत सिंपल प्रॉब्लम है बेटा। देखिए, मटेरियल स्ट्रेंथ कोफिशिएंट के वैल्यू इट इज गिवन, हाउ मच, 210 megapascal. Okay, initial height it is given 20 mm, initial height या initial thickness you can say. Final thickness या final height is given 15 mm, reduction. Radius of roll it is given 450 mm. Velocity of roll it is given 28 meter per minute. Width of the plate it is given 200 mm. Exponent it is given 0.25. We have to find force in kilonewton is what? Done. Strength coefficient it is given. So what do we know that the mean flow stress is equal to flow stress divided by n plus 1. Nothing it is given, we can apply this thing. That means this is flow stress is what? K into epsilon pe power n divided by n plus 1. So what is my next target? This is first equation. Now, then we have to apply this. If stress is there, then we have to find the force. How? This mean flow stress into length of contact into width. Clear? Simple thing. If nothing it is given. So what is that? My first case is to find the true strain. So ln initial by final, higher by lower always. So ln initial is how much? 20 divided by 15, and that is equal to 0.2875. Okay. So from here, equation first, we can easily find the flow stress, mean flow stress. What is that? K. K is how much? 210. Epsilon is how much? 0.2875. Per power 0.25. 0.25. Per power 0.25 divided by n. N is what? 0.25. That means 1.25. If you calculate, we can easily find mean flow stress 23.03 megapascal. Once you have a mean flow stress, apply the equation number second. So from second, what they are asking? They are asking that roll force required. Rolling force required F is equal to mean flow stress into length of contact into width. So mean flow stress just now 123.03 into length of contact is how much beta? We already find, no. Oh, length of contact, no. So we have to find length of contact. Length of contact is equal to square root of R into draft delta H. So R is how much? R is how much? 250. So 250 into delta H is what beta? 5. Delta H is your 5. H I minus H. No? So this is your 47.43 mm. Once you have put this value 47.43 and width it is given. How much width? 200. So this is your 200. So how much it is? Force 1167.16 kilo. Simple. So either the equation it is given in this form, or it is nothing will given, strength coefficient given, we can form this equation. Very simple. Don't. So beta metal forming, the student says that sir, they are very tough, but question is very limited type of question. Okay. now. Okay, done. Let's discuss the next problem. Yes. A cylindrical billet that is 100 mm long and 50 mm diameter. There is a billet. So that is 100 mm long and 50 mm diameter. It reduces, see, there is indirect backward extrusion to 20 mm diameter. The die angle, obviously it is 90, so not required. The Johnson's equation, there is a Johnson equation. We'll discuss this thing. In the Johnson equation, there is a parametric term A is constant and B is constant is there. It is given. The flow curve of the mark material has a strength coefficient K value and the strain hardening exponent N value it is given. Determine the extrusion ratio, number first, true strain, number second, number third, ram pressure, number fourth, ram force. Okay. So it may be MSQ type question. Okay. This is your MSQ. Which of the following is correct? This is your, my dear, very important. Which of the following is correct? There is a numerical value it is given. So it is MSQ type. It may be in the range of MSQ type question. In the GATE examination, the value it is given, value it is given, value it is given, value it is given, extrusion ratio value it is given, true strain value it is given, ram pressure the value it is, force, ram force the value it is, and they then question क्या करेगा आपको, question ये करेगा which of the following is are true. So that is the MSQ category. Clear? So I will give you again 1 minute time. You take a 130 second. Okay, just start.